Hello, this is Vesa Juvonen from Microsoft, and in this video we're looking into declarative agents within the Microsoft 365 Copilot. So what they are, how do they behave, and how do we create them? We'll actually focus on three different things. So first of all, why would you create agents? So what are the agents and what they actually bring on top of the Microsoft 365 Copilot? Because the Copilot is smart and aware of all of your enterprise information about you and also, of course, information within the internet. So what is really the value of the agents in this discussion? The second thing, what we're going to talk about is the programming of the agents. So what does it mean that we're programming large language models, and the significant difference comparing to the classic programming when we write something like if person writes X and Y and Z, then do something else. Within the large language model programming, it's really different way of approaching things. We're using natural language to define those rules, and we'll show that one in practice. And the third thing, what we're going to show in here is that how do we use the Teams Toolkit to create a custom declarative Copilot agent, which you can then adjust based on your business requirements. We're going to keep it super simple intentionally. There's much more advanced scenarios available with declarative agents, but we need to start with basics and then we can start adding more capabilities on top of it. But hopefully you'll enjoy the video. So let's talk about the Microsoft 365 Copilot and why do we actually need those agents. So that's a good topic to start, and then we move into using one of the example declarative agents, and then we actually move into the creating one. But first of all, here we are in Microsoft 365 Copilot. This is the same Copilot which is then available in the Office clients or in SharePoint or in Teams and so on. Depending on where you're accessing it, it has the same capabilities behind the scenes. And you can kind of consider the Microsoft 365 Copilot as a generalist. It is not really fine-tuned or polished or targeted to really be specifically helpful on a specific area. You can talk about, you can ask questions about your tasks, your emails, your content, your files, and all of that stuff, but it's really not fine-tuned, for example, for coaching you on writing, even though you can ask about that stuff, and it's really capable of answering that. But there's a kind of adjustments which you can do with agents on the behavior. And with agents, you can also include additional plugins, additional actions, additional behaviors, which are not necessarily available in Microsoft 365 Copilot. So as an oversimplification, well, not an oversimplification, but a simplification, the Microsoft 365 Copilot is the generalist, and then the agents are the ones which are really targeted on a specific functionality, on specific behavior, specific tone, for example, helping people on writing better stuff for the internet. So here is a really good example, writing coach, which is one of the out of the box or agents which are available directly from the store for free, which is provided by Microsoft. So how do you get access on this? You actually go to the Get Copilot Agents functionality in the Copilot UX, and you're able to then see all of the different agents which are available. And in our case, we're going to just search, for example, learning. We can see then learning coach, career coach, writing coach, with really good examples of a free agents which are specifically targeted for a specific functionality. So for example, helping around your career development or analyzing your skill gaps and all of that stuff. So giving you a specific functionality and specific input on that specific topic. So they've been adjusted based on the system prompt to provide them a different set of behavior than the default Microsoft 365 Copilot. And that's basically the difference here. So as an example, if I go now back on the Copilot, this is again the generalist, and then the learning coach and writing coach has been adjusted from a behavior perspective to focus on certain specific areas. And there's multiple ways of actually doing that within a declarative agent or in agents in general. Now, a kind of a simple example, what we're going to do today within this walkthrough is the geolocator game sample. This is based on something which is actually available in the Copilot developer camp, which is a great set of material to get familiar about the Copilot extensibility. There is two different paths in here, which is the extend Microsoft 365 Copilot or build your own agent, which gives you even more flexibility. So you don't just use the Microsoft 365 Copilot as a baseline and adjust that. You actually build your own from ground up. So there's two different paths. And then the extend option has the first declarative agent, which is quite simple, but this is basically walking through the scenario what we're going to do today within this video. Now let's go back on the experience in here and let's have a look on this one. So this is geolocator game. So first of all, really, if we start thinking on how do we implement this kind of a chatting and natural language-based implementations using LLMs, this world is fascinating because the implementation style is so different versus the, let's say, previously used bot framework kind of a style implementation, where we were trying to figure out what is the intent of the user, and then maybe trying to detect individual words, what the user was saying within the chat, and then trying to desperately figure out in the code what were they actually trying to do. But in this case, as we're using LLM and natural language processing behind the scenes, we can actually do magnificent stuff without complex implementation of actual code. And let's walk through first this experience, and then let's go back and have a look on how this was actually implemented, or how we would implement one of these geolocator game examples, because it actually walks through the creation of a custom agent, and also how we are programming or adjusting the behavior, how the LLM is giving us responses back using, in quotes, the system prompt. So we are doing prompt engineering and prompt tuning based on the business case. Now, in our case, this example case, this is a geolocator game. Again, the real source code is available from the Copilot camp material, so you can have a look on there. There's a small adjustments which are done here, but that's completely fine. But basic idea here is that I can start a discussion or a game with the LLM. And behind of the scenes, it is the same LLM, which is part of the Copilot, Microsoft 365 Copilot, but I've adjusted this to be a game. So basically, welcome to the geolocation game. It will give us clues, and then we're trying to guess which city it is actually referring to. This city is located in the continent Europe, is known for a temperature maritime climate. Let's guess, is it Paris? And it's not Paris. Okay, so the city is famous for canals and a historical city center that is UNESCO World Heritage Site. That is interesting. Would it be, maybe, is it Amsterdam? Oh, that was correct. Okay, so cool. So we were able to already play around the game. Let's do one more round. Let's say play again, and notice I'm doing a intentional typos here. So, and because it's an LLM, it understands me still. It's able to kind of understand, regardless of the typos, it's able to understand my intent, which is brilliant. Really, really one of the example of the advantages of what LLMs and natural language processing can provide us. So this city is located in Asia, is known for its hot desert climates. What would it be? Let's say Jakarta. That's not really hot desert climate, but let's actually play around with that. Jakarta is not correct. The city is known for luxurious shopping, ultra-modern architecture, and lively nightlife scene. I can guess what it is. So let's actually say, is it Dubai? And that is correct. So now we have 2 cities, clues, and earn 8 points. So if we would have implemented something like this using a classic bot framework or classic, let's say, chatting capabilities and classic implementation of the code, think about how would you actually do this? So you would have to detect what the user is writing. You would have to kind of understand the potentially typos and figure out, oh, there's a small typo, but it was meant to be a Dubai. And then the points, how would I actually calculate the points, and calculating how many clues and all of that happening before the person and the user was able to figure out the right answer. Let's do one more round. And it's able to obviously understand that that means that I want to play one more round. That's one more thing. And again, I can say my text or intention in multiple different ways. And because it's an LLM, which is natural language processing, it's able to figure out again my intent, which is, hey, let's play again. This city is located in South America and is known for its tropical rainforest climate. What would it be? For the sake of it, Peru is not a typo. Peru is not the thing. It's certainly not the thing, because Peru is a country, not a city. But that's a different thing. City is famous for carnival festivals, samba music, and beautiful beaches. Could it be Rio de Janeiro? And I'm saying Rio. And it's able to actually figure out again, it was, yes, indeed referring to Rio de Janeiro, and that is correct. So now I can say, what's my points right now? So how do I get to my points? And the geolocator game is able to explain to me how do I get to the points. And I can actually have a discussion with the LLM or with the game. For example, I knew the Amsterdam on first guess. Please update the score. Which is a bit of cheating in my case, because of course in this case the LLM has been adjusted to be super helpful. So it's actually adjusting, as you can see. It fixed my first answer to be, okay, cool, you knew it from a first guess, and now I have 26 points. Obviously we can adjust all of this behavior as part of the system prompts, but it really shows you the power again. I can have a discussion with the chat, and how would we implement this using traditional coding, traditional ways of doing things versus how we're doing that using LLM. And that's really the mind-boggling difference here. So how was this actually then implemented, which is so different comparing to the bot framework implementation? So let's actually do that. Let's move into Visual Studio Code. Let's create a new solution. We're going to do this from scratch. So I'm going to create a new application. And in our case, first of all, we're using the Teams Toolkit. Teams Toolkit is available directly from the extension section. You can easily find it. And then I click the create an app button, which then opens up this section in here. And we can see different kind of functionalities, what we can actually implement using Teams Toolkit. And one of them is the agent option. So let's actually click that one and start creation of things. And right now, the only option within this version, what I'm using, is declarative agents. And there's going to be more options available here in the future. So let's create a declarative agents. And in my case, we do not have an API plugin. API plugin would be a bit more advanced scenario. We're able to actually connect the declarative agents to an external APIs and external systems using API plugins. A really, really great opportunity of making the agents even more, declarative agents even more powerful. But again, we want to keep it simple on this video. So let's create a declarative agent. And then we can use the default folder. It doesn't really matter. In this case, let's call this GeoGuessr game. Awesome game. So we're able to differentiate. Minimum 2 letters, exclude certain special characters. It needs to begin with letters. Okay, so let's try GeoGuessr game v2. Just that we're differentiating from the example which I already had on the system. Let's actually trust the folder. That's fine. Let's increase that one. Let's increase the font a bit so we're able to see what we actually got from the baseline creation. And it actually shows me the README file. But let's close that one, and we are in here. First of all, as we are inside of the Teams Toolkit, the Teams Toolkit is able to understand the default configuration what I have. For example, since I had already connected to my example tenant, it's able to detect that connection. In my case, we're not going to use a connection to Azure because we're going to keep things simple in this particular deployment, so we don't actually have to worry about that one right now. But let's see what it actually provided us. So first of all, we have the default setting, which is the Teams Toolkit solution package. And inside of that package, we have the basic functionality, which is the Teams manifest. And Teams manifest file is technically the same for Microsoft 365 applications or Copilot applications, Solem. And in here, we have then introduced a Copilot agent section, which is then defining that within this solution, when it's going to install, and this contains actually a declarative agent, and the file and the configuration for declarative agents is that JSON file. Okay, cool. We could have multiple other options here available, but we don't have to worry about it right now. We could have a different custom images and logos and all of that stuff like we had with the example case. We don't have to worry about it right now. In the declarative agents, this is where we can configure how the functionality or how what are the information, what are we exposing for the end user. So let's actually do that a bit. So this is GeoGuessr game v2, and that's the name. And then we have description, which is visible for the end user when it's actually installing that. So that's actually really cool, or should be understandable for end users. And then we can have conversation starters here, which will help the end users to actually understand what the functionality is available. So I can do conversation starters. And that is actually an array of a JSON objects. So let me copy a few examples here directly here. And we can, for example, have something like get started. I'm ready to play geolocation game. Give me a city and guesses, blah, blah, blah. Medium level, let's focus on Asian cities, and advanced level, just cities in UK. I would not really do well on that one probably because I don't live in UK. But it's a really good example of a functionality which we could provide as a starting point. For the LLM and for the agents, we're saying, hey, let's just focus on agents, cities in Asia, which then changes the behavior of the functionality, which is really, really cool. But how does it actually do that in practice? Now, let's have a look on that. So first of all, for the declarative agents, the most important thing here is really the instructions. So this is basically defining in natural language what are the function behavior and what is the behavior what this agent should be doing. So let me actually change here. Here we go. Finally found it. No wrapping or wrapping enabled. So this is now the default instructions for the declarative agents, how it should be behaving. So if you're familiar with the system prompt concepts, that's what this is. So basically when user is using the agent, how it should be behaving and what are the ways how it should be giving results, or it should be calculating something, and what is the experience for end users. How did we do that calculation and points and everything else? Let me copy the configuration which we have for the geolocator example. So we're basically saying you are a game host for geolocating guessing game. Your goal is to provide player with clues, player instructions, game instruction prompt, blah, 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 blah. Clue 1, provide general geographic clue. Clue 2, landmarks. Clue 3, cultural clues on the city, offer specific clue, blah, 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 blah. And this is where it actually gets interesting. If you go back on the experience, which we had a look on here. So it basically gave me different options on the city. For example, for the Rio, it talked about Carnival Festival, Samba music, and beautiful beaches, which I never wrote it to do. But what I wrote and told it to do is that for the second clue, for the Rio, offer a hint about cities, landmarks, and natural features, famous moments, rivers, and all of that. And basically, the agent or LLM behind the scenes then decided, okay, because we're talking about Rio, it is famous for Carnival Festival, and I will provide that as the text as the clue. So we are programming or making the behavior different using natural language within the instruction TXT file. And that's really the key difference here. So we don't actually write code as in if, then go to, or switch clauses. We are in natural language explaining the behavior, what it should be providing for end users. And also, if we scroll a bit down here, we're also providing the points. So we don't actually save the points anywhere. We don't actually need to get track on that. It is getting all taken care of by the LLM and the context. But we're technically saying if person gets selects or chooses or guesses the city with a second clue, it is 8 points. And if it's only one clue, it's 10 points. And if we go back on here, we even had the discussion related on, hey, we told it that, hey, you were wrong. I actually guessed Amsterdam in the first guess, and it was able to update all of the points. How did it was able to do that? Well, it had all of this guidance and information in natural language, how it should be behaving. So we are doing programming in natural language rather than, again, writing actual code, which is really, really cool and a great example of how LLMs and agents are changing even the implementation style of our solutions, because this is a solution. It is a solutions for providing specific functionality for end users, which is really, really cool. Cool. Okay, so here's our example. By the way, looking on the instructions, there's a lot of information in here. We do have a specific documentation available for you in our learn.microsoft.com, and there's Microsoft 365 Copilot and extensibility is the location. There's also write efficient instructions for declarative agents guidance here, which is based on those free Microsoft provided agents. So all of the learnings what Microsoft has internally related on what works, what doesn't work, what we should be taking into account is provided as a guidance on how do we do things, which is super, super cool as well. Now, that is our declarative agent. We are technically ready to go. And how would I then test this? Quite simply, I could actually go to the Teams Toolkit. Teams Toolkit has a simple functionality called provision, and it will actually provision this application to be available in my developer tenant. And that was the tenant which is I'm connected in here, and that is the tenant which we were just using as an example. So now what happens here, if we open up the steps, let me actually open up the terminal. So we can actually see the output. Nope, debug console. Nope, output, terminal. Somewhere in here, we can see what's actually happening. And it's all clear. Anyway, so now if we go back on the deployment, so let's actually do this one more time so we can actually see, is it actually visible? Output panel, there it is. It was too hard to find. So here we can see it actually is doing validation. It makes sure that it's, things are working properly. There's additional documentation as the deployment, and then it explains what it actually does, which is super, super important in output panel. I need to remember that. But basically, it does walk through what did it do, what did it doing from a deployment perspective. Update was executed successfully because it was able to find that application already within the system. So now if we go back on the Copilot and we do refresh, actually the refreshing was automatic. I can now see my GeoGuessr game V2 already available for me for a testing perspective. So let's actually click that one. And we can see that that's the image, that is the default settings. And now I can say, let's start the game. And I can start testing the functionality. How is it working? Now, if I click the new chat, we can of course do something else. As an example, we added this medium level. Let's focus on Asia cities, or advanced level, just cities in UK, which is actually really cool functionality as well. When I think about it, we don't need to program a specific list of cities and villages in UK. We're using LLM to give us a random clue within the UK. And of course, it is able to understand, again, that we should be only targeting the villages and UK's cities in UK. Cities located southernmost part of UK, known for its maritime history. Let's say London. Just for sake of it, testing. London is indeed southern part of UK, but it's not the city we're looking for. Founded in 13th century. It is getting too hard. I would not be able to actually get too many points on this one. So will not go that well with the cities in UK. But it shows you the example of how simple it was to create a custom functionality. And again, the most important thing, the programming is actually in natural language as we're writing against the LLM and defining the functionalities for this particular declarative agents. Now, in this case, like we mentioned in the intro section, the UX and experiences, all of that is relatively simple. So we're not tying in this declarative agent to files within a SharePoint or a website in the URL or a API source where we could be able to do actions. That would be a bit of a more advanced scenario, but all of that is possible. Already as such, it is providing us a unique specialized experience for, in this case, for GeoGuessr game, but it could be something else. You can have a long system prompt adjusting the behavior, how the agent should be working, focused on, or how the agent should be behaving, and what are the topics it should be focused on, rather than having this generalized Microsoft 365 Copilot, which is a generalized person. And again, the agents are the specific specialists for providing special capabilities for that particular use case. But that's a quick intro on the declarative agents, what they are and how to get started, and how we're using the Teams Toolkit to get started using them. We strongly recommend you to test this out. There's a lot of great capabilities available. And then, of course, we'll have more and more guidance and videos available on more advanced topics, for example, connecting declarative agents to graphs and images and writing or executing code and connecting to APIs and all of that stuff. But that's for another video. But thank you for watching on this one and give us feedback. Thank you. Cheers. Bye-bye.